Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. And if you find my videos interesting and important to your studies, also don't forget to subscribe. So this is problem 42A. There is a request from one of my subscribers and I accepted the challenge just right now as I am available. So this is problem 42 and I called it example problem 42A. So this was analyzed as recommended by the authors, Miriam and Craig, from their books, that we should analyze this as approximately as a parabolic cable. Now, the analysis, the exact analysis is it should be a catenary. In fact, I established a ratio which is 10% based on my established ratio or condition for the cable to be approximated as a parabolic cable. And the sag to span ratio is more than 20%. In fact, this is about the average is more than 10, 12 plus 9, that's 21 over 100, that's 21%. So the result should be somewhat, there's a big discrepancy to the result. But if you change this based on my established ratio, for instance, 12 will be changed to 5 meters and 9 will be changed to 4, so that we'll have a total sag through the horizontal line through B of 9 over 100, so that's 9%, then the answer would be close, very close to that of problem 42. So anyway, I solved this using the original data. So I let's locate the origin. Distance from the lowest point to the origin is C. This is the x-axis. XA is equal to x sub C, which is this, and x sub B is 100 minus XA, as shown in the table. So the working equation tension at B is mass times acceleration due to gravity G equals the uniform weight of the cable times YB. So that's the tension from catenary equations. So W is given, so our problem is really YB, where YA is from the figure C plus 9. So our working equation is this in computing for that mass. So YA is C plus 9, while YB is C plus 9 plus 12 or C plus 21. So that is XB, which is 100 minus XA. So again, YA is C plus 9. So it is C cosine hyperbolic of XA over C. So therefore, XA is C times inverse hyperbolic cosine of C plus 9 all over C. So that is the value of C. While YB is equal to C plus 9 plus 12 or C plus 21, and it is C cosine hyperbolic of XB, which is 100 minus XA over C. So C plus 21 equals C cosine hyperbolic of 100 minus XA. Let's substitute the value of XA, which is this, and we should approximate the value of C, or using the high-tech calculator we can solve for C. So using the high-tech calculator, or if your calculator is not high-tech, you have to try values of C. You may start with 60, increase it because the sag is small, so we expect C to be high. So solving for C, C is 89.536 meters using the high-tech calculator. Then we can now solve XA, which is 89.536 inverse cosine of quantity 89.536 plus 9 over 89.536. So XA is equal to 39.816 meters. Therefore, the horizontal distance AC is 2 times x sub a, so 2 times 39.816 meters. So distance AC is 79.63 meters as compared to the approximate value of 79.12. So there is a big difference. As I said, if you want the answer to be close, my suggestion is solve this again, replace 12 by 5 and replace 9 by 4. Then we expect almost the same results. Then finally, for here, YB is C plus 21 and we have found C. So therefore, M times 9.81 equals 25 times 89.536 plus 21. So the mass is 281.7 kilograms. So there's a big difference to the answer. It was 206 to 70, I think. So there's a difference of 11.7 kilograms because, as I said, uh, this is the exact analysis. But if you change this to 5 and 4, the answer would be closer. So that's it for this problem. I hope that the the one who requests the solution, exact solution, will be satisfied with this solution here. But for other problems, in the future, you should try to solve it by your own. The only way to learn is to accept the challenge and do not let me solve it for you. I can make, there are a lot of challenging problems on cables which I reserve, but for the subscribers, some of them will be discouraged, especially challenging problems. But I like those who are challenged by the difficulty of the problem or problems, but you should attempt, they should attempt to solve the problems by their own, not to pass their experience. For instance, the difficulty of answering this problem, because it will not help. You should do your share also. Okay, that's all for this video.